My name is Christopher Lozinski. I'll be speaking about the ZODB Blogory today. Primarily, I'm going to be talking about ZODB. I'm developing on top of ZODB with Grok and Zope, and kind of it's very lonely out there, so I came to this conference to meet similar people, and very pleased to meet a bunch of people who are doing similar things. So Blogory is a content management system, and it's a hierarchical blogging software. The idea is sort of appeal to the mass market. And the part of Blogory that's best developed is the part related to ZODB, so mostly we'll be talking sort of about the state of the ZODB. This afternoon's talk about rel storage was really targeted more at the mainstream sort of corporate, high volume traffic Plone people. I'm much more interested in sort of small one-man shops, entrepreneurial stuff, all kinds of interesting and odd things that people are doing with ZODB. When you go to the ZODB website, it tells you about when to use it, when not to use it, but really the time to use ZODB is when you're trying to change the database. So if you're trying to change something in Postgres, forget it, no chance. But if you want to do something really unique and custom, and others have done and are doing very interesting things in ZODB, then it's way faster to do it in a Python-based database. Okay, so can we go to the concepts in Blogory? So usually if you're looking for something, scroll down some. Usually if you're looking for something, you'll do a Google search and you get 1 million results. And 1 million results is great if you're a computer, but for us humans, it's really very difficult. So I don't want 1 million results. I just want a tree, maybe 7 items in each thing, and then I can dig into the branches of those tree. And to build that tree, you can't, Google strategy is to do everything automated. But if you want a good taxonomy related to a technical subject like ZODB, you really need people to build that. And as I've traveled around the world, there are so many intelligent, hardworking, intelligent people. You've got way more than enough people to index the entire internet. So I can't do it all single-handedly, so I'm starting with just ZODB, a little tiny piece. Okay, and then let's scroll down to some of the software ideas that drive me. I really believe that you want to program on a graph of persistent distributed objects, sending messages to each other. And so ZODB gives me that abstraction. It gives me that huge simplification. I don't worry about writing to the database. There's just, it gives me a conceptual model. It's very powerful, very flexible. So I basically, in the last year and a half, I wrote 3 different applications, Apache, PrivacyV, and Blogory, single-handedly part-time. Why? Because I have this wonderfully productive software development environment. And then the other part is you really want a system, the whole system where your information is sold, you post on LinkedIn and they sell it to advertisers. It's just wrong. You need to control who has access to your professional information, your Facebook postings. You need some kind of privacy control over these things, and that's what I did on PrivacyV, which we'll talk about later. Okay, can we go close this one out and go to the next one? Okay. So those are the kind of the key concepts. If we could scroll down, that would be wonderful. So let's take a quick look at the Blogory software stack. Starting off at the bottom. So of course it's based on Python. On top of that, I got ZODB. On top of that, I've got the Zope toolkit. I mean, wonderfully powerful stuff. But for the average developer, if you want to bring up a site quickly, you don't want to be messing with ZCML. And so Grok gives me just a wonderfully fast development environment. On top of that, I built Zopachi. Zopachi, for those of you who use Zope 2 through the web, Zopachi is like a modern version of it. I've got HTML objects. So there used to be just DTML objects. I've got HTML objects and CSS objects and JavaScript objects and Jade objects and Z classes, and the whole stack sort of done correctly. And then on top of that, I have Blogory CMS. And the idea is to get, I've been looking for some other people I respect to also contribute content, so it's a multi-user person, but it's also a blog where postings go up immediately, as opposed to a more traditional CMS where things go through an edit review cycle. I may go through an edit review cycle, we'll see. And then finally we've got the database, and of course no one cares about the software, they care about the data, and all of the links in there about ZODB actually do interest people. One guy actually said that he found the website yesterday. I was like, whoa, without... So there's a lot of good stuff about ZODB, and if we can close this one out, we'll go start talking about the ZODB. Zope knowledge base. So this is actually split between 2 websites. My old website, which was the first, Zopachi.com, has a whole bunch of stuff about Zope and ZODB. And then the new version, the multi-user CMS, is blogory.org. And so can we make a smaller font size? Control minus. It's okay if you can't. So, okay, so basic introduction. What does ZODB give you? It's really easy to use. If you're a Python developer, it is so easy to attach ZODB to your thing. You basically just subclass. You subclass off persistent object, you subclass off persistent list, persistent dictionary, and persistent set. And suddenly your whole Python application becomes persistent. It's like brilliant. I mean, every Python developer should be using this. It's heavily used, particularly in the Plone community. My instinct is it's less used in Pyramid because they tend to do a lot of relational stuff. And it's also reliable. Everybody I've talked to has been just totally happy with the reliability of ZODB. Okay, so when do you use the ZODB? And this is actually taken from the ZODB website where they talk about lots of reads versus writes. Let's see, what else? Sorry, I don't remember everything. Oh, when you have complex relationships. So if you have a graph. So that's the classic thing, but really use ZODB when you want to do something innovative with your database. And so there are a bunch of things that people are doing that I'll talk about later, shortly. And you want to know when not to use ZODB. I met one guy who was using a ZODB for a file sharing application. So every time you grab some data for a file, you have to record something. It's a very heavy write application. You don't want to be using that. But let's go take a look at the related websites. And scroll down some. Keep going down. Okay, so first one is persistent Python. We can click into that. So basically it gives you this very easy to use persistent Python, and it gives you transactions on top of persistent Python, and you can store your big files in blobs, and does all kinds of really nice things. Let's close that one out. And one that's surprising is, so I always think in terms of graphs, and if you look at Pyramid or ZOP2, it was a common, you can, click into, it's for graphs. One of the common misperceptions on in the ZOP2 world was that ZODB was only for trees, for hierarchies. And even some of the people I spoke to here just thought it was for trees. ZODB is a proper graph database. And so let's go into, it's a proper, so Mr. Fasten's article was the one that cued me into that there. And let's actually just go an example. So I'll now show you privacyv.com. So I run a Plone job market. I run about 70 different job markets on privacyv. Everyone says they care about privacy, but the fact is nobody cares about privacy. Everybody, who has a LinkedIn account here? Okay, and who cares about privacy? Okay, who raised their hand twice, right? People don't care. But okay, so if we go into, go into the example ZODB. So I've got a hierarchy of job boards. You can see there's software engineering. You can click up to Python web frameworks. So these are people who have experience with Python. You can go into general software engineering. You can go back down. It's basically a tree. Okay, everybody gets that. The interesting thing is if you go to, say, candidate 17, okay, we click into candidate 17 and scroll down, he's got a list of different skills here. And so here you have a tree, and here you have the candidate. And the candidate links back into the tree, right? And in fact, the tree links into the candidate. So we can go back to Plone, and it'll take us back. So it's a proper graph database. Questions about this? All very clear. Feel free to ask me questions at any time, and if I get anything wrong, I'm going to be covering a lot of things. If I get anything wrong, just point it out. It's okay. Okay, so that's that. Let's close this one out. So it's a graph database. And people talk about using relational databases for graph database. The Coty guys came up yesterday, and I was discussing on the ZODB mailing list why ZODB is so much better, and particularly if you have a folder, and you have a folder of heterogeneous types. In ZODB, in Python, you just say, for items in folder, do the following, right? It's really easy. And they said, oh, you can do that in, can we close this one out too? They said, you can do that in a relational database. And I said, you can? How? And so they said, well, it's easy. Here's the code for it. How many lines of code do you think this is before, let's go into it. How many lines of code do you think this is? Pardon? Scroll down. Go, 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 go. Keep going, keep going. You may want to go faster. It's just like ridiculous. This is from the Pyramid documentation. It's like, forget it. I don't want that much complexity. I just want it to be simple. I want to do something innovative. I need it to be simple so I can do something innovative. ZODB gives me that power and flexibility. Sure, you can do anything and anything, but it's just way too hard. And so this was from an email from a pyramid advocate. Close it down. I'm not going to name him. Okay, what else do we have? Features. Heterogeneous. So particularly if they talk today about large corporate organizations, you just hand it over to the system administration people and they'll manage it, right? Well, I'm not a large corporation. I'm a one-man shop, and I spend half my time doing other stuff. I need to keep it simple. And so this way, I just have Python. I don't have to mess with any Postgres administration. You've got object history, which is really wonderful. You can store blobs on Amazon. There's all kinds, for reads, it's really, really fast, everyone reports. So it's got all kinds of nice features. It's got transactions. If you go to MongoDB, and there's a link here about the people who tried to do diaspora on MongoDB. So diaspora is a Facebook-like application where everybody owns their own node. And so there's no central control, there's encryption, you've got privacy, really cool stuff. They tried to do this on MongoDB, and of course, when they were doing transactions between nodes, MongoDB wasn't doing the transactions correctly. So they gave it all up, they went to Postgres, but then of course you can't run Postgres on your cell phone, not a chance, right? So, okay, so that's, I'm not going to talk too much about concurrency and control. All kinds of tools for distributing ZODB data, let's go into that. And we're about to go off website, but UbiquDB, if you want to do a chat application, right? Chat servers are very different from web servers, right? So web server, you get a request, you respond to it, you drop the connection, not a problem. A chat server, it's got to keep the connection alive. So things like, Meteor, right, do chat servers very, very nicely. Things like Twisted do chat servers very nicely. Historically, ZODB and chat servers don't mix, and actually there is a guy trying to do chat servers on top of ZODB. Let's go, okay, now we're going to go off-site to my old website, more distributed data links. But there are a whole bunch of ways that you can distribute data with ZODB, and people don't even know about all of these things, right? So everyone knows about ZO, and we know about relational storage. There are a couple different versions of blob file. There's the Plone blob file, the Z3 blob file. But you can also store all of your stuff in Amazon. And actually, ZODB Corporation, which basically no longer exists, did a whole bunch of stuff with storing massive quantities of stuff in Amazon. And they do it all transparently. So you write it, and it stores it out to a file, and in the background, it pushes it up, and your transaction carries on. It's all just really gorgeous stuff. Okay, what else do we have down here? One person did ZO RAID, where they have like a single ZO server with several different RAID servers, not a typical RAID server, but just a ZO RAID server, so that even if one dies, the other ones are still available. I did pickled trees, so I'm doing recruiting, and I want to bring in a candidate. A candidate's a complex object. Maybe it has 20 objects in it. And to access each of those as a separate disk access would just be painfully slow. So what I do is I pickle them all together, right? And one of the amazing things people don't talk about in ZODB is you have so much control over your transactions. You can decide which objects get pickled together. If you want to do a transaction, when it writes a transaction, it writes all those objects in the same place. So what you can do is you can just hit the p changed, and you can say, listen, all of these things, I want them to be stored together. So you can have tremendous control over how you store stuff. If you think of your application, it's a big graph, and you've got lots of different transactions, and you want to decide which stuff gets stored together, so it's all accessed in a single disk access, and you have complete control over that in ZODB, and don't even think of trying to do something like that in Postgres. I mean, I can't even think of how to do that in Postgres. Okay, anything else down on this one? I think we're done with this one. Let's close it out. Actually, scroll down just to make sure there's nothing left. That's it. Okay, close it out. Okay, so that's on distributed data. Any questions about distributing your data? No. Okay, close this one out. Competition. So, okay, let's take a look at this ZODB competition. Well, certainly Amazon we all know about. We know about relational databases. Let's see, PostgreSQL. PostgreSQL is really good, but again, if you try to end, Postgres actually does trees. But if you try to do this heterogeneous trees in Postgres, I don't know. If there's a Postgres expert here, I'd be very interested in having. I've had different opinions on this one. Next, go down. That's it? Okay, close that one out. ZODB framework. So it turns out a whole bunch of ZODB frameworks. ZODB is tied in with Django. It's tied in with Flask. We know about Pyramid and Plone and ZOP2 and Grok, although not many people know about Grok, I guess. What else do we have for ZODB frameworks? Framework, I think, yeah. Okay, so we've got ZOP2 and Plone and ZTK, and there's a Django ZODP, and there's a Pyramid, and ZTF. Oh, ZTFY was another one. Thierry Florac from France did it. He eventually just gave it up because and he went to Pyramid because no one was using it. I tried using it, and then Zopachi is my version of ZOP2 on top of. Okay, so lots of different frameworks use it. Am I missing any? There are probably some other ones I don't even know about. ZODB performance. Let's see how we're doing on time. Okay, that's 15 minutes into it. Let's see, we can skip this one. There's some personal notes from some people. This guy's doing some very interesting stuff on encryption. We'll get to that in a minute. ZODB forms, can we click into that? What you have to look at when you're looking at ZODB performance is write performance versus read performance, right? And you have to look at small systems versus large systems. So for read, it's really brilliant. At the other talk, they actually said that there's no cache invalidation in rel storage. And so if you've got something where the stuff basically stays around and you don't invalidate your caches very often, then you can gang up a bunch of different ZODB, I guess, ZO clients together. You can do, there's another technique, which I missed in the distributed section, sorry, called ZOP replication services, where you can make a copy of your ZOP database in real time. And as every transaction rolls off, you get a guaranteed message going to the other version. Well, if you can use that and you've got an application where there's a lot of reads, Blogory, for example, is, only I write and a lot of people read it. Hopefully a lot of people read it. If you're doing where there's a lot of reads, you can use ZOP replication services to create a bunch of replicated copies of the ZODB, and you get tremendous performance out of reads. You can't beat that. On the other hand, writes are slower. Certainly if two people are like doing a conflict and trying to write on the same thing, then writes they get into conflicts and they back off and they get really slow. So one of the performance that took me a while to understand is you have to, when you talk about performance, reads and writes are very, very different beasts. The other thing is small databases. The earlier version of this, I used these pickled trees, and basically there was just a single object in RAM. And man, was that server fast. It was like as fast as Google servers, and Google's got these servers all over the place. So if you've got a small database that can stay in RAM all the time, you're going to get tremendous performance also. Okay. Large databases. Of course, you have to keep your blobs out of the database, and you can store them on the file system, or you can store them on Amazon S3, or lots of different options. We also talk about ZODB on SSDs. So typically, if you have a ZO server, there's a single ZO server process that's accessing the hard drives, and the hard drives are the rate limiting factor. But if you move it to an SSD server, and SSDs have gotten so cheap, my ISP, I almost moved it to SSD. I will after this conference. I didn't want to break it. It's just the same price, whether it's an SSD hard drive or a real hard drive. And so the SSDs are faster than the ZO server process. So that's another consideration in performance. Okay, let's take a look at ZODB scaling. Sharding, let's see. Oh, okay, can we scroll down here? Oh, that's it, okay. So, so the question that I didn't do well on last time was when people asked me, what about scaling up the ZODB? And It's clear. I mean, the rel storage example today was that they're twice as fast as ZODB, and Jim Fulton is aware of this, and we were talking. He wants to, put the time and energy to make it into a multi-process server as opposed to a single process server. Although maybe that's not really where the performance is. But there's a sense that you've got these massive databases, and ZODB doesn't quite compete in that space. And the reality is, so what Jim says is that the applications he's actually seen, they don't really have to scale. Once you push your stuff out to blobs, the core data is not that large, right? And we talk about sharding as ZODB puts everything in a single file system. Imagine if you put it in multiple file systems, that might be better. But then you get sharding, and then you've got to do two-phase commits across those different pieces, right? There's some things you can do. For example, you could, let's just say there's some innovative things you can do here, and I'm happy to talk about it afterwards. It's not quite clear what to be done, but there's ways you can partition your data. And one simple example is for your catalogs, you can update the transaction on your data first, and then afterwards update your data on your catalogs. And there's this whole issue of consistency that they talk about. In many real-world applications, it's okay if different parts of your database are slightly inconsistent. So certainly if you're adding a new item to your database and it doesn't show up in the catalog for 30 seconds or so, that's okay, nobody's going to see. So there's some situations like that. There's some things you can do. I must have missed it here. There was one database they do in manufacturing where they've got vast quantities of data. And so what they do is they split the database across many, many different nodes. This is the Neo database. They split it across many different nodes, and they have a central server that hands out sort of transaction IDs and object IDs and tells you where they are. And that ends up being the bottleneck. But they can handle vast quantities of data that way. So the point is there are some other ways of splitting up your data and distributing your data and sharding it that don't quite have perfect consistency, and the solutions are out there and people are starting to see it, but it's not quite clear what can be done there. And it's really very application specific. So in my particular application, I can tell you what can be done in your application, and as opposed to just at the database layer where the database vendor doesn't know anything about the application, they can't do this kind of stuff. Questions? Okay, sharding. Okay, I guess that's it for this one. ZODB on SSD, ZODB scaling, reliability. Let's keep going. Anything else? Is that the end of the page? Okay, let's close this one out. Close this one out. So ZODB for Kiwi. This is so one of the talk today on rel storage is really for large MIS applications, right? But the really interesting thing is, what if you want to have persistence on cell phones? So there's a cell phone application development environment called Kiwi. It's all Python. It's really good. If you're doing an iOS app, for example, if you really care about performance, then you'll do it in Objective-C. But if you don't have anything too complex to do, you can do it in Kiwi, and then it runs on all these different platforms. And you get into the question of what you do for persistence. Well, you could use ZODB. Android is multi-threaded, that the user user process gets multi-thread, so that would work fine. Evidently on iOS, the user developer only gets a single thread, and then when you do packing on ZODB on iOS, it blocks. So that's a problem. It's fixable. But I think, particularly in the sort of the diaspora world, all these, who needs a web browser if you have Python on your client, right? Not totally accurate, but kind of. Okay, so there's a whole bunch. Okay, so that's kind of the ZODB. Oh, let's close this one out. So let's see. Oh, sorry. Back to related websites. Sorry. And is it down? No. Okay. So close both of these out. Sorry, it's up one. Go back to the original. There you go. ZODB roadmap. So this is the interesting question: is where is ZODB going in the future? And a lot of people are really passionate. They really, really like ZODB. One of the issues is encryption and signatures, and sort of the typical application for encryption is backup. So the story goes, you want to make a backup, but you don't want somebody else to have your data because there's all kinds of company proprietary. Or even if you trust, and even if you encrypt the whole thing, right? They would. Sorry, even if you trust them, they could get a court order, and then they would just hand over all your data to the government, and then as part of a court hearing, all of your proprietary data would be part of the court case. So evidently, so backing up your encrypted data is really good, and there are at least 3 different ways I know of how to do this. One is the fancy one is use ZOP replication services, and you just encrypt your transactions as they go, and you send them off. When you need to, you bring the whole bunch back and decrypt them, right? And one guy he's really pushing it to the extreme. He's encrypting the indexes, so he doesn't want anybody to know what's going on. And so when you access an index, you bring the whole index to the client, you make it a larger fetch, you decrypt it, and then you say, okay, this is the next bucket I want. So he's actually not only encrypting the data on the client, but encrypting the whole indexes on the client as well. So, I don't know, maybe that's an interesting idea. Search performance, we talk about Solr and talk about Elasticsearch. Elasticsearch is unstructured. Solr, sort of, you need to know what the fields are. You can do it simply with an API call, but then if you can lose a transaction. And so what Jim wants to do is, again, tie it into the ZOP replication services, that whole transaction machinery. So once a transaction commits, you're guaranteed it'll show up in the Solr Elasticsearch database as well. Json Api. Certainly on Postgres, you've got JSON-B, which gives you you serve your JSON out to the client, and then you store it in Postgres, and it does all those conversions correctly. People talk about JSON, instead of doing pickling, doing JSON formats. Then you maybe lose the security. So probably what makes sense, although if there's a different opinion, I want to hear it. Probably what makes sense is you unpickle your Python object, you do all your security checks, and then you publish your JSON. So it seems to be the mainstream solution. But then one guy is doing a JSON query API, so you can actually just send your queries to the Z catalog with JSON. And Jim Fulton and I are also both very interested in defining your Python classes, really using Z classes, ZOP.schema types of things. Define your schema for your server using JSON, and then it becomes a proper JavaScript JSON server. And of course, you have to be aware that JavaScript has just numbers, and Python has floats and integers, so you get a bit of a problem there. Okay, JSON MPI, embedded, this whole embedded Kiwi, cell phones topic. Can we scroll down to the next ones? This whole multiprocessor thing, although it appears that the multiprocessor is not the limitation on the servers. Keep going down. Oh, and then this whole distributed data, the whole diaspora thing of distributing data. So say I have a node and I have a copy of my address, and 20 other people have a copy of my address, and you have a node and 100 people have a copy of your address. So sort of distributing your data, not across a central concentrated data server, but across lots of tiny nodes on the internet is kind of a different direction that's kind of more my interest, less Jim's interest. So that's kind of where ZODB is going. And any questions about ZODB before I move on to the next section? No. Okay. Okay, we can close this one out. So let's actually take a look at, do you want to log into Blogory? Do you have the blogory.org/login? In fact, there are not too many people, so if you have a laptop, you can actually log into Blogory. And in particular, the whole Plone community uses TinyMCE, which is kind of ancient. I'm using 2 different editors. One is the ACE editor, and the other is the CK editor. ACE editor is a technical editor. You edit the HTML, and it gives you error checking. And CK editor is a WYSIWYG editor. And so if you go ahead and log in, it would be guest at blogory.org. blogory.org, and the password is guest. You're welcome to log in. So it's a tree, and under software engineering, you have permission to post stuff. So if you go into software engineering, you can add a link to, I don't know, let's add a link, and let's see, just call it PloneCon. No, PloneCon. Plone conference, there you go, and call it Plone, wonderful Plone conference. You can type in the URL. So here's the, you can type in the URL. You probably need HTTP in front of there. but I'm not quite sure. Oh, you can see if it works or not. Type in some description, wonderful conference. So in Blogory, you always have the description, which is there's a long list of things, and then you have the content afterwards. Wonderful conference, and you can type in some content. And so this is not a very impressive demo of the, well, this is the technical editor, the ACE editor. But you can say, just type in hello, just type in a space, and hit the create object, create and edit. There you go. And of course it said, yeah, there are errors, so you have to have HTTP in front of it. In front of the URL, you have to have HTTP, ://. Okay, so create and CK edit. And down here, you get the CK editor. And it's just this rich, wonderful WYSIWYG editor. You know, it's got all the font size and underline and, you know, everything you can imagine. You can type in some text, and he's never even tried it. Go ahead. Type in some formatted text, sir. And so that's the CK editor. Okay, let's do, there you go. Let's do a submit. Actually, submit is at the top, I think. I'm not quite sure. Nope, it's at the bottom. Save. And so the Plone content, when you do CMF, Content Management Framework, and Plone, you just have a single object. What I actually have is two objects. And so there are two copies of the of this particular object. One is in the group directory and one is in the private directory. And particularly when you move to distributed systems, then one can go on one server, one can go on the other server. And so let's go up to the menu options, and we can go to CK view. You can view the group or you can view the private. So let's take a look at the view group. And so that's his new link. And if we go back, this is in the group directory /group. And if you can go to view private, and you can go see it in the private, and you can edit in the private. And so a contributor has permission to edit in their private directory, and it shows up in the group directory, and the group editor has permission to edit in the group directory. So okay, so that's ZODB, Blogory, the ACE and CK editors. Questions? Anyone using encryption with their data? So one of the interesting topics is that everyone's encrypting their backup data. And so I'm just wondering who here is encrypting their backup data and trying to engage some conversation here. Go ahead.
You're at the end of your talk, or is it now?
That's it.
Discussion?
Yeah, it's open for discussion.
Yeah, first, I appreciate your passion for ZDB and all the stuff around, but I have lots of objections.
I'd love to hear them. Bring them on. Maybe I'm wrong.
Well, I guess ZDB was a perfect database, let's say, for the last 15 years, and it's still perfect, but...
Well, perfect is for depending upon what the use case, right?
Yeah.
Okay.
Exactly. And you know, say it, the use case depends on, and each project has different requirements, and requires a different tool for building the best solution. So
yeah, so I don't say it should be used for everything.
No,
yeah, that's fine.
No, but for example, you're saying that, for example, ZDB is also a graph database. That's nonsense. ZDB is a tree-based database. It's hierarchical.
It's graph-based, right?
It's a tree. You can build a graph with any database, and somebody can do it with ZDB yourself.
Okay, let me actually refer to Fasten on this one. Okay, can we back up to? Blogory, go down to software, Plone. Actually, yeah, don't go, okay, Plone. Keep going, open up. So I'm going to refer you to, it's rather than arguing, I'm going to refer you to Fassen's article on it, right?
We can discuss that tonight as a party.
All right. But okay.
After 2 glasses of wine.
Right.
My point is basically, the world moved on over the last 15 years, and there are a lot of new databases, like everything within the NoSQL world, from Cassandra having certain, giving you certain features, giving lots of restrictions. MongoDB is a piece of shit, as you all know.
I don't know much about Cassandra.
There are also some less known databases, for example, like OrangeDB or ArangoDB, which are a mixture of document stores and graph databases. So you have to look at your problems and then make a decision about which database to use.
Yeah, I'm fine with that. Yeah. The guy this morning, the guy downstairs who does the Plone hosting. He was saying,
Christian.
Pardon?
Christians.
Yeah, he said, for these we use relation, for these we use ZODB,
Exactly.
and I have no problems with different. And
I also made some remarks already on Twitter on your plans for CDP next generation or whatever it's called. The plans are okay, but do you have the resources? Do you have the budget?
My job is just to be an advocate for ZODP, right?
Sure.
So
I'm just realistic. And
would you like to volunteer to help on some of these projects? I'm not.
Actually, I was attending 2 weeks ago in Berlin at the conference about distributed, and there was a guy which is known on Twitter as Afire, which has this eventual consistency block. And he took a look at 15 different distributed systems and checked them about their claims about consistency and functionality in case of network errors and so on. And 14 out of 15 systems had very bad issues. So going with ZODB into a distributed world like multi-master and so on requires a lot of knowledge and manpower and years and so on, just as a side note.
Yeah, so my big claim is ZODB is great if you're a Python developer because it's in Python, and so I can change it easily. And
it just depends on what you're doing. Yeah. And for example, in my talk yesterday, we're using Plone as central CMS because it's perfect. But for, in our case, publishing, we use other databases like XML databases with a tight integration into Plone. So basically saying, okay, CDP is a database for all and everything is often the wrong approach.
Yeah, well, the other thing I'm doing Zopache. I didn't talk about it. It's a browser-based development environment. I'm doing Z classes using Zop.schema, and so I do that all very happily on the ZODB. That whole stack works very nicely. Other questions? Thank you for coming.